This is problem number 32 in your worksheet. Pause the video, solve it, and check your answer. You want to start by drawing the forces in the picture because this is at static equilibrium. There are 5 forces. There's a force from the hanging weight, which I will label F1. You have a weight force from the bar because a weight was given, which is Fg, and it's going to be midway. We are going to have a tension along the rope, and then you will have a force at the hinge right here up here. Since the majority of the forces are going up, chances are there is a vertical force going up. If you drew your vector incorrectly, the answer will come out negative, so that means your vector actually goes in the opposite direction. We have a horizontal component at the hinge because tension is at an angle, so it provides an x component to the left. So at the hinge, it must go to the right. Step 2, we should pick a pivot point. The pivot point is the point with the most unknown, and the most unknown is at the hinge, so this will be our pivot point. So now I write a sum of torque equation. Sum of torque is going to be the torque of 1 plus the torque of the weight plus the torque of the tension plus the torque of the pivot. This has to be equal to 0. We know the torque of the pivot is equal to 0 because we stated that torque is equal to force times perpendicular distance from the pivot. Since the pivot is the 0 or reference point, R will be 0. So this is why the pivot point torque cancels out. Now I need to start plugging in. So torque 1 is going to be F1 times R1 plus torque of the weight is going to be Fg times R of the G plus torque of the tension is torque tension times RT. This is equal to 0. F1 is given as 100 newtons. R1 is from the pivot point, which is down here, and the weight is hanging all the way to the end, so that's going to be 10 meters. So we know F1 and R1 are not perpendicular, so we need to make them perpendicular. So the first thing I'm going to do is I'm going to draw a horizontal line across. If I draw a horizontal line across, this pink line on the bottom is parallel to the ceiling right here. Since this bar is at an angle, we know this is 155 degrees. That means because of transverse angles, this is also 155 degrees. Right here above, this makes a line. A line is 180. 180 minus 155 gives an angle of 25 degrees here. So the angle down here must also be 25 degrees because 180 minus 155, or because the lines are parallel, alternating interior angles are the same. So I'm going to redraw F1, but I'm going to shift it up. So if I drew my line like this, we know that this is my bar, this is my pivot point here. We know this is F1. And we also know this is 25 degrees. Now I'm going to plug in for my weight. My weight is given as 15 newtons. My radius, or my distance from the pivot point, is going to be 10 meters divided by 2 because the weight is at the middle of the bar because it's uniformly distributed. my weight is not perpendicular to my lever arm, so I need to determine if it's cosine or sine. So I'm going to redraw my picture. So if I redraw my picture, my weight is going to be right here. This is FG. We already know this angle is 25. So if it's perpendicular to the earth, you just bring it straight down to the earth and it will make a right triangle right here. So this is a right triangle. This is still FG. So if you notice, we're going to resolve the lever arm because the lever arm is the hypotenuse. This is 5 meters. This is still 25. And this is next to, and this is the component that is perpendicular to FG. This is going to be cosine 25. So the weight is also cosine 25. You could also use sine of the other angle, 90 minus 25. So now I'm going to plug in for tension. We don't know what tension is, so we just plug in T. We know RT is going to be 10 meters because it's at the end of the bar. I'm going to redraw my picture. This is my pivot point. My T goes slightly this way. That's my T. And I'm going to label it T. So we are going to bring the tension down to make it perpendicular to the lever arm. So what I'm going to do is I'm going to take my lever arm and I'm going to extend it a little bit. So if I extend it a little bit, I'm going to bring this straight down. This is perpendicular. So my T is my hypotenuse. So I need this component right here. This is the component I need to make it perpendicular to my lever arm. This is my lever arm. So I need to solve for that angle. What is that angle? So I'm going to extend this bar. So if you look at this, this whole thing is 155. This is a line. So this angle here is 25 degrees. So that means if I have my tension angle, which is right here, this is 10 plus 25. So this angle right here is going to be 35 degrees. Because if I draw my triangle, it's going to look like this. So it's 180 here. This is 155 minus 180, which is 25. This gives you this angle, 25. But I need this entire angle, so it's 25 plus 10. This is why it's 35. Since it's opposite 35, so this is going to be sine 35. Now I'm going to figure out direction. So for the 100 newtons, this is my pivot point right here. This is my force. My force is pulling the bar down. So if it's pulling the bar down, it's going to rotate counterclockwise. So this one is going to be positive. If I look at my weight, again, this is my pivot point. So we first locate the pivot point. My force is being pulled down here. So it's going to pull the bar down, which will rotate counterclockwise. So this one is also positive. On this one, this is my pivot point. If I pull my bar this way, it's going to rotate clockwise. So my tension here is going to be negative. So T becomes 198 newtons. So now I'm going to write a sum of Fx equation. Sum of Fx is equal to my H going to the right minus my Tx going to the left. This is equal to 0. So H is equal to Tx, which is equal to T cosine 10 degrees. So this becomes 198 newtons cosine 10 degrees equals to 194 newtons. My sum of Fy is going to equal to, we have V going up, we have tension Y going up, we have F1 going down, minus Fg, which is going down. That is equal to 0. So V is equal to F1 plus Fg minus Ty. This is F1 is 100 newtons plus Fg, which is 50 newtons, minus 198 newtons sine 10, which equals 116 newtons. So my pivot point has a V going up. It has an H going across. So if I draw my parallelogram, it goes from the tail to the tips. This is my R. This is my V. This is my H. So my resultant is V squared plus H squared. Take the square root. V is equal to 116 newtons squared plus 194 newtons squared. Take the square root. This is equal to 226 newtons. Tangent theta, I'm going to do the angle from the horizontal to the north. So this is opposite over adjacent, which is V over H. This is equal to V is 116 newtons divided by H, which is 194 newtons. So theta is equal to 30 degrees northeast. This is number 21 in your textbook in chapter 9. We have a pole that's holding up a traffic light. They want you to find the tension CD, find forces at A. So pause the video, solve the problem, and check your answer. So if you drew your forces, there should be 5 forces total. So there are 5 forces on this picture. We have one from the traffic light right here. So I'm going to label that F1. We have one here at the midpoint for the weight of the pole. So I'm going to label that Fg. We have a rope CD that has the tension. And then we have A, which has 2 forces. We have a force going to the right, which I'm going to label AX. And then I'm going to have an upward force, AY, because both the F1 and Fg are going downwards, so AY has to oppose it. So now I'm going to write a torque equation as I did before, but first I'm going to pick a pivot point, and the pivot point I'm going to pick is the one with the most unknown, which is point A. So my torque equation becomes torque net is equal to torque of F1 plus the torque of the Fg plus torque of the tension plus torque of the pivot point, which is A. And again, since it's the pivot point, it's going to be 0. And so my equation becomes F1 R1 plus FG RG plus T RT. This is equal to 0. So if I plug in for F1, F1 is given as 21.5 kilograms. Since it's a force, I need to multiply by 9.8 meters per second squared. It is at the edge of the bar, which is 7.5 meters long. So it's going to be 7.5 meters in distance. So my F1 and R1 are not perpendicular to each other, so I'm going to redraw my picture. So this is my pivot point. This is my bar. This is my weight of the traffic light going downwards. I'm going to draw my CD bar here because this angle is given as 37 degrees in the problem. I'm going to draw a line parallel to it on the bottom next to the pivot point because now these angles are alternating interior angle. So this is also 37 degrees. Since the force F1 is perpendicular to the earth, I'm going to bring it straight down. When I bring it straight down, it is perpendicular to the lever arm. My F1 is still F1 here, but now my hypotenuse is the distance of my lever arm, which is the bar, and I need to find this component which is perpendicular to my F1. So I'm going to use cosine theta, which is cosine 37 because it's next to. So this becomes cosine 37 degrees. Plug in for the weight, which is 12 kilograms. Need to convert it into newtons, so times 9.8 meters per second squared. Since it's midpoint of the pole, it's going to be 7.50 meters divided by 2. And again, the vector, my force and my lever arm are not perpendicular, so I need to redraw my picture. So that's my lever arm. This is my pivot. My weight of the bar is halfway down, FG. We know that my chord here, CD, makes a 37 degrees angle, so therefore if I draw a line parallel to that line, this angle is also 37 degrees. Since it's perpendicular to the earth, what we're going to do is we're going to just take that vector and bring it straight down. If we bring it straight down, it makes a right angle. Since it makes a right angle, we're going to resolve the lever arm. The lever arm is going to be 750 divided by 2 because it's halfway, right? And so this is 37. So this is going to be cosine 37 because it's next to. This is the lever arm we want because it's perpendicular to FG. So this is also cosine 37. Now I'm going to plug in for T. So T is what we're solving for, and RT is going to be 3.80 meters. If I redraw my picture, this is my pivot point. This is A. My pivot point, that's my lever arm. This is my CD. This is perpendicular to right here. And that was labeled as 3.8. So it was already perpendicular, so you didn't have to do X and Y. Now I'm going to solve for my direction. Here's my pivot point. And my force, I pull it down, it's going to rotate clockwise. So my F1 is going to become negative. Here's my pivot point for the weight. I pull it down, it's going to rotate clockwise. So this one is going to be negative. This is my pivot point. My tension is going to the left. So if I pull it, it's going to go counterclockwise. So this one's positive. So if I solve for t, t is going to equal to 424.8 newtons. Now I'm going to write a sum of Fy. My sum of Fy, we have Ay going up, opposed by Fg, the weight of the bar, minus F1, which is the weight of the traffic light. This is equal to 0. So A1 is going to equal to Fg plus F1, which is 21.5 kilograms plus 12.0 kilograms times 9.8 meters per second squared. This equals 328.3 newtons. My sum of Fx is going to be Ax going to the right minus CD going to the left, or you could replace this by tension since we labeled the tension equals to 0. So Ax is equal to tension, which is 424.8 newtons. So at point A, we have a vector that is going up, which is Ay. We have a vector going to the right, which is Ax. If I do my parallelogram, my resultant starts from the tail to the tips. So my resultant is going to be Ay squared plus Ax squared. Take the square root. Ay is equal to 328.3 newtons. Need to square that. My x is equal to 424.8 newtons squared. Take the square root. This becomes 536.9 newtons. My angle is going to be measured from the horizontal, which is this. So tangent theta is opposite over adjacent, which is Ay over Ax, which is equal to 328.3 newtons divided by 424.8 newtons. So theta equals to 37.7 degrees. This is problem 27 in your textbook, chapter 9. Pause the video, solve it, and check your answer. So first we're going to find the pivot point, which is located at C because it has the most unknowns. So my general torque equation becomes torque net is equal to torque from the wall, or the normal force from the wall, plus the torque of the painter, plus the torque of the ladder, plus the torque of the pivot point, which cancels out because my R, which is the distance from the pivot point, is 0. Now I'm going to plug in, so it's Fw times Rw plus Fg person times R of the person or the painter, Fg of the ladder, R of the ladder equals to 0. So this one, you could find the angle if you want, which is tangent theta. Opposite is 4. And adjacent is 3. And if you solve for theta, you get 53 degrees. But in this problem, you don't really need theta because all the lengths are provided for you. So if I look at Fw, we do not know, so we're going to be looking for that. Rw has to be perpendicular to it. Since Fw goes this across, perpendicular to it is right here. So Fw is going in that direction. Perpendicular to it is the height, and that was 4 meters. So that means the distance is 4 meters. So now I have the weight of the painter, the weight of the painter was given as the mass of 55 kilograms. So I need to multiply 55 kilograms by 9.8 meters per second squared. If I look at the weight of the painter and if I redraw my picture, if I bring it straight down because it's perpendicular, they gave you this distance as 2.1 meter. If you notice, that's perpendicular. So this is going to be 2.1 meters. The next one we're going to plug in is the ladder's mass, which was given in kilograms. So I need to multiply by 9.8. And my distance, I'm going to redraw it again. So if I redraw this, they gave me the ladder, which is in the middle. The entire length of the wall was 3 meters. So that means it's going to be halfway. So it's going to be 3 meters divided by 2. Why? If I bring this vector down, this is perpendicular. So it's this direction. If I bring this vector down, it is again perpendicular. So it's this distance. So this is equal to 0. So now I'm going to account for direction. So if I look at the first one, which is FW, this is my pivot point. So if I pull my FW to the left, it's going to rotate counterclockwise. So that's positive. This is positive. This is my pivot point down here. If I pull this force down, the bar or the ladder is going to rotate clockwise. So this is going to be negative. So this is negative. If I pull this down right here, which is the center of mass, and my pivot points on my left, it's also going to rotate clockwise. So this is going to be negative, and this is negative. So I'm going to solve for FW now. FW equals to 327.08 newtons. So now I'm going to write a sum of Fy equation. My sum of Fy equation is Cy, because it's going up, opposed by the weight of the ladder, opposed by the weight of the painter. This is equal to 0. So Cy is equal to Fg plus Fgp, which is equal to mass of the ladder, 12.0 kilograms, plus the mass of the painter, 55 kilograms, times 9.8 meters per second squared. So Cy is 656.6 newtons. My sum of Fx is going to be my Cx minus my Fw. This is equal to 0 because these are all in static equilibrium. So Cx is equal to Fw, and Fw is 327.08 newtons. So if I look at my ladder is going to slip this way. This is my motion. Therefore, friction has to be in the opposite motion. So that tells you Cx is my frictional force. Frictional force is equal to Cx, which is equal to mu n. And so mu is equal to Cx over n. My Cy is the same thing as my normal because it is being pushed up from the ground. So we said Cy is equal to 656.6 newtons. So if I plug this in, this becomes Cx over Cy. Cx we found as 327.1 newtons divided by 656.6 newtons. So my coefficient of friction becomes 0.50, and coefficient is a ratio, so it's unitless.